So you can see here again the complete solution is asked. So complete solution is particular solution plus the null solution x3 and xn. Okay, so this is particular solution and this is null solution. That is particular solution, you are keeping b as it is, and null solution you are making assuming or you are equating b equals to 0. So just solve instead of a, your matrix n is given. That's all. The notation has been changed to n. So you can solve it as usual, augmented matrix, and then you can see you have a augmented matrix. M is written here, and we have M, we have B, and then just just go on solving this. The first non-zero element is 1. You make this 0, and just check it what happens by the row operation. So here you have u, and you can stop here also. In this u, you can see the element has already, all elements have already become 0. So for this to be solvable, b3 has to be equals to 0, and b4 should be equals to, and this also should be equals to 0. That automatically means b4 equals to 3 times of b2, because these two rows are equals to 0. A into 0 should be equals to 0. So next is the same problem we are solving for the null space. We are finding it here null space xn. So I have equated this b is being equated to 0, and we have the solution x1 plus 2x2 equals to 0, x1 equals to minus 2x2, and just write the expression for that. So here you have the free variable is x2. You can see this is free variable. So I am writing the expression for x2, and that is, what is the value of x2 in x1? That is minus 2. What is the value of x2? That itself is the variable itself. So this is your special solution, or the what will be the special solution? Only x2 is there, so making x2 equals to 1. If another variable is there, that you have to make it 0 and this equals to 1, and later that variable equals to 1 and this variable equals to 0. So that is how we find the special solution. And when you have a single free variable, it is left as it is. So finding out the x particular solution, we are leaving we are keeping as it is. The values are b is kept as it is, and equation is written, and x1 becomes b2 minus 2x2. If I set all the free variables equals to 0, what is the free variable? X2. If I set it this to x2, so what will be the value of x1? That is equals to b2. That will be writing in the particular solution. For the null solution, you will be setting the free variables, one of the free variables 1 and other 0. Here you will be setting all the free variables equals to 0. You can see here in the particular solution, x1 is equals to b2, and at x2 you don't have any free values, so that is it is x2, that is free variable itself is made 0. Then only you are getting the xn value. So just write down xn and x3. That will be a total complete solution. So here another problem is asked. So describe the set of attainable RHS for B. So already you had this, we have seen this type of problem. So attainable means just reduce this A to U or to R. So if you reduce this to U, and if you get 0, 0 at the last column, and the augmented matrix, this also term has to be equals to 0. If that is 0 equals to 0, we have to check, and that itself is attainable. So here this one, you can see here we have solved the problem from A to U. We have U, and it is nothing but equals to R also. R and U are equal. So you can see if this A0, A into 0 has to be equals to 0. So what will be this? This has to be equals to 0. That means what? B3 equals to 2 times of B1 plus 3 times of B2. So this, if this is satisfied, then we will have an attainable solution. So that was asked in the problem. One row is 0 row, and the two are linearly dependent. Hence, the rank of the matrix. Here, what will be the rank of any of the matrix? The number of non-zero rows itself is the rank of the matrix. In this problem, you can see here this non-zero rows are, this is one non-zero, this is another non-zero, and this is total 0 row. So we can say rank of the matrix R is equals to 2. So here the problem is that reduce A to echelon form to find their rank. Which variables are free in the find the special solution to A is equals to 0. Special solution you get it from Xn. So that is nothing but null space. So null space is then you equate B equals to 0. And to know you have to reduce A to echelon form. The same procedure you use. Reduce this to 0. Then check the second row, check again the non-zero element. This is 1. And already it has been 0. Only one row operation is required from A to U. So what is the rank? There are two rows which are non-zero, and hence the rank of the matrix is equals to 2. Which are the free variables? These two x1 and x2 are paired elements. So these three, that is x3 and x4 are free variables. So and next what is asked? Find the special solution. So you take this u into x equals to 0, equate it to 0 and find the special solution. That first find the null solution from the variables. Here you have a special null solution x3 and x4. From this you can find out a special solution, that is this is your null solution. So first one you make x3 equals to 0 and x4 equals to 1. Later you make this one and this equals to 0. Then you get two columns, that itself we call it as two solutions, that itself we call it as a special solution. So this I have written here. You can see this is special solution, this is special solution. Coming to next problem. Find R for each of these row matrices and the special solution. This problem also, which is similar to the previous problem. Here A is given and here A comma A. So write B equals to A, you write it A twice and it will become size of this B becomes 6 cross 6, and here it becomes 3 plus 3 6, and here again 3. So 3 plus 3, that is 6. Here sorry, it becomes 3 cross 6, and here becomes 6, and here it becomes 6 cross 6. Just write A, then next A appended with A, next below also A, and another column 0 0 0. So this is how we will be writing, and just reduce them to R. It is asked R, so reduce into row reduce echelon form. So you can see here first R is made from this R. If you want, you can arrange this, you can shift this non-zero element here, or because if you below this you don't have any elements, so try to arrange them. If you leave it also, you can solve it as how it is. But what happens is that the second non-zero element, this 3, you won't be able to identify. So if you are solving it, the first non-zero element will be this, and if you try to make this 0, it remains as it is, and the next paired element will not be getting. So for that sake, you can change this row. You can just shift the rows as you want. Or in some cases, you can leave this as it is, and you may get paired element in first and second. You can do that also. So here you can see A has been solved, and next similarly you can solve it for AA here. A is written, A is written, A is written, and so you have 3 cross 6. So similarly, same procedure you adopt it for solving. Reduce A to U, U to R, and then solve it. And here again you have A 0 0. This also you can see. You have A 0 A. So this you can subtract it if you want. You can apply the row operation here itself, or write the values as matrix A as it is, and then you can apply the matrix row reduction. The option is left to you. Either you reduce this and then equate it, or you can change the normal rows also.